Hi everyone, this is Kona, and we are going to actually work on analyzing or going through and looking at some real data. So first of all, here is that body part data right there, and what we're going to do is copy it and then come over here and paste it in. Now you'll notice that when I pasted it in right here, you can see that I put the guess hand size, actual hand size, age, gender, all of those went into this top heading, and the numbers are what started the 1, 2, 3. So make sure, because that's something I see sometimes, is if you have the title or the column, what it is, down in the 1, 2s, in through here, it will not calculate correctly. So, okay, so we just copied and pasted the body part data into here. So what are some things that we can do? So if you wanted to say, well, here we've got the guess hand size, actual hand size, age, gender. Well, first of all, let's think about this data. So let's pull that up just a little bit. So in looking at it and thinking about it, does knowing the guessed hand size and the actual hand size, well, great. But what does that really tell us? Well, I don't know. Let's look at, come over to stat, actually right here. Yeah, we'll do a graph. Okay, so let's do this and let's look at a scatter plot. So let's go ahead and do a scatter plot with the regression line and click OK. And so let's go ahead, put the guess as the Y and the actual as the X, and click OK, and let's see what we get. Alright, so what we're seeing is the guess hand size as our Y, the actual hand size as our X, and we're just graphing it to see how close they are to this line. Now the closer it is to the line, it means the better people are at guessing and getting right their actual hand size. In this case, it looks like some people are pretty good. Those would be the people who are kind of right along the line. In other cases, some people are really not very good. So like this person, you know, their actual hand size was 22, but they were guessing closer to 18. So versus this person right here, who they guessed 18 and their actual hand size was just a little over 18. So okay, that's pretty cool, right? So that's something that you could say, well, in general, people did a pretty good job, right? But there were some outliers over here. So what else, and I'm just going to go ahead and minimize this. So what else can that tell us? Let's see. Well, you know, going back to our data here, what we really want to know, right, is the difference between our guess hand size and our actual hand size. So to do that, we're going to use that calculate function. Go to the calculator. Now the big thing here, well, first of all, so store results in variable, and let's call it difference size, the difference in the size. So the big thing is we want the difference between the two of them, but we don't really care if it's positive or negative. So we're going to actually use the absolute value, and then where it says number, we're just going to go ahead and delete that out and instead put the guess hand size minus the actual hand size, and then click OK. So you see how we're calculating the absolute value. So remember, absolute value takes whatever is in that parentheses and basically it makes it positive. So if it's a negative, it becomes positive. If it's positive, it stays positive, but it's the absolute value of whatever's in there. So then we click OK. And so here we've got the size difference. So we know that it's 1.6 difference for this person. Wow, 4 for that person. So, all right, so that's interesting, looking at the different sizes, but how is it relative, right? We haven't really made it relative to what? I mean, what if some people had really big hands, some people had really small hands, so maybe 0.25 isn't too much because their hand size was only 16 or 18 centimeters. Well, what if their hand was closer to 30 centimeters? You know, 0.25 might mean something. So what we need to do is actually take these and make them relative to the overall actual hand size. So how is that actually related to the overall hand size? So to do that, what we're going to do is come back over to calculator, and we're going to call this relative, because we're making it relative difference. So we're making a new variable here. And for this one, we're still going to use that absolute value, so we're still using all of that data, except now we're going to divide it by actual hand size. And let's see what we get. Alright, so this is now actually the decimal value. So if we want it in percent, so it's like, okay, well that's interesting, but what's the actual percent? Because this is the relative value. Let's take it, go back to calc again, and this time we can put parentheses around. And why am I putting all these parentheses in? Because order of operations. Just like on your calculator, you have to do the order of operations, you have to do order of operations here. Let's multiply it by 100, and we'll turn this into a percent. Okay, so relative size difference, here is the actual percentage difference between those. So here you can see a 1.6 is actually 6% difference compared to the 4, which is actually an 18% difference relative to the person's actual size of their hand. So this is where these percentages, oh wow, like 13%, that's kind of crazy, right? Well, it's 13% here because they're 3 off from that 22. So basically we're taking that 3 and dividing it by the 22 to get that. And to see that, you just go back to calculator, and you can say that we are doing our actual minus, or I'm sorry, the guess or minus the actual over the actual, and then we're timesing it by 100. So hopefully that makes sense. So now we've got the relative size difference. So who do you think was better, men or women, at guessing the relative difference in size? Well, one way we can look at that is by going to Stat, Basic Stats, Display Descriptive Statistics, and we can say the relative size difference is our variable, and the variable is the actual number, and then by variable, this is where we can use a categorical. So for this one, let's go ahead and use gender, and you can click the statistics and you can get all of these different ones. I'm just going to leave it the way it is right now. Click OK, and here we go. And so the overall mean, you can see that females had a mean of 2.3% difference, where men had 7.3. So what is that saying? Is that women seem to be a lot better at estimating their average hand size than men did, right? Now remember, we're only doing descriptive statistics. So we are not doing inferential, so this does not prove anything. It just seems to appear like, because women had a lower mean of 2.3 compared to the 7.3. So that's 2.3% compared to 7.3% relative difference in their ability to judge their hand size. So, okay, that's kind of cool, right? What else can we do? We can also just get some basic statistics overall. So what if we just wanted to know overall relative differences in sizes? We could click OK, and then we can just get overall the average is 4.48 for all of the relative size differences. What this did was break it apart by male and female. And then what this was showing us that it's 4.48, I'm sorry, overall mean. So what if you want to know, and granted I can see you can male and female there, but what if you're curious what the age break apart was, right? So what's that difference in age? You can come to tables, tally individual variables, and so for this one, let's look at age. And let's do both of those. Yeah, we'll just do all of them. So here we can see the age breakdown. So we can see we had 5 students who were between 18 and 22, 5 who were between 23 and 27, 1 who was between 28 and 32, 2 that were between 33 and 37, and 1 that was 38 plus. So the percentages here is just overall, that's 35% of the group, 35% of the group, 7%, 14, and 7, just kind of going through. But there you go. So if you're trying to find out, and remember, for these discrete variables, what that means is this is a categorical variable. So that's why. So if you're wondering when you would use descriptive statistics versus when you would use the tables, the tally individual variables are for categorical variables. So like we could use this one for gender. And we can see male, female, and other right there, right? So that's the tally for the discrete variables, which are your categorical variables. For your display descriptive statistics, this is going to be for actual numbers. So this would only be for, you could use the guess hand size, so actual hand size. So we could do that one and say, okay, people's actual hand size on average is 21.129. It doesn't really tell us anything, but that's where you would get those basic statistics at. So let's see, we've gone through calculate, we've done some basic stats, some display descriptive statistics. Something else you can do in tables and down here in these descriptive statistics for tables is go through and say for categorical variables. So let's say for gender, and the columns are going to be age, and click OK. And you actually get a breakdown of how many females were 18 to 22. Well, one female was 18 to 22, and 4 males were 18 to 22. And for females, so this kind of just gives you a breakdown by those different categorical variables. So if you're interested, how many females fell into the different age ranges versus how many males, and then in the other. So let's see, so we've done that one, and we've done this one for today. Let's see, let's look at graph. So we did the scatter plot. So what else could we do? We could also do a dot plot. So let's go ahead and do a dot plot with groups. And in this case, we're going to do the relative size difference. And for the categorical variable, let's go ahead and do gender. And in this case, you can click around on these, and I'm not going to show you every different option here. So you can click around and play with them, but we're just going to go ahead and click OK. All right, so what this is showing you is the dot plot. And you can see that the men have a much wider distribution here, right? Because here's the difference. And so you can see that men range all the way from 0 difference, which means that guy was actually able to get it identically perfect, his hand size, his guess versus his hand size, versus way out here. And remember, this is percentage, so this isn't in centimeters or anything, but percentage-wise, look how huge that is out there, right? So the other is right there, and the females, you can see, are grouped a little bit closer. So this is why when we were looking at up here, when was that one? Okay, so when we were looking up here, remember where we said the mean is 2.3 for women and 7.3 for men? Yeah, well, that's where you can really see it here in this box plot. And you could also do it by age, but it's probably going to look a little uglier. Gender is probably a little bit better here. Now for the data that we have, in all honesty, I think the scatter plot or the dot plot are probably the best. But if you want to play around and see if you can come up with something, you know, interesting or something you think makes sense or looks cool, go for it. These are just the ones that I'm recommending, and these are some of the more basic ones for this type of data. But I think I've gone through, go ahead and cancel. I think about the only other thing is making sure that when you go to capture this data, so when I say that you need to include this in like a document or something, what you're going to want to do is if you come up menu, it allows you to copy that whole part. So menu, copy it, and then go into your Word document and paste it in. And I do want all of this. So if this was your stuff, please turn in all of this versus menu. There we go. You know, copy. You can copy as a picture. You can also send that to Word. So if you already have a Word document open, you can also send it to Word. So there's lots of different things. But when I ask to see your actual data that you analyze, or the data, this is what you're turning in. Your menu, copy, and then paste that into your Word document, and then make sure to tell me what it is. So I think that's it for now.